Okay, so I got two qubits here. I'm doing a multi-qubit gates here. I have a Hadamard gate on the first qubit. I have a Hadamard gate on the second qubit. And I have a measurement gates on each one of these lines for the first qubit line and then the second qubit line. I have a measurement gate on the third qubit line, but don't worry about that because I don't have a gate on that line, so it's irrelevant. All right, so let's play this. All right, so I played the Hadamard gates for each qubit line. And when you remember when I said you have two qubits and there's a Hadamard gate on each one of those qubits, it represents, it equals out to having 4 states because you have two qubits each with a Hadamard. So that's the equivalent of a total of these two qubits can be in any of 4 states, and that's represented here with these blue colored circles. Okay, so now let's do the measurement gate for both qubits. Okay, now remember when you have a qubit in a superposition with the Hadamard gate, there's a 50% chance it goes to either the 0 state or the 1 state. And then you go to the second qubit, same thing. When it's in the Hadamard superposition, they can either go to the 0 or the 1 state, and there's a 50% probability. And you can see that over here, 50% chance that it goes to 0 or 1, 50% chance it goes to 0 or 1 here. In this case, they both went to 0. The first qubit went to 0, the second qubit went to 0, and that's what you see here. So if I do this again, that probably will change. So let's try that again. Okay, it went back to 0 again. Well, each qubit is in the 0 state. Let's try it again. Should show a different state. Okay, see, in this time, the first qubit is in the 1 state, and the second qubit is in the 0 state, representing these two first numbers. All right, let's try it again. It should change every time. Well, most of the times I do this, it should change. Remember, there's a 50% probability on each. So let's try it again. Okay, this time the first qubit is in the 0 state, and the second qubit is in the first state. So let's try it again. Okay, this time the first qubit is in the first 1 state, and the second qubit is in the 0 state. Let's try it again. Same thing. Let's try it again. I'm gonna try to get it where the first two qubits are, the two qubits are both in the 1 state. I'm trying to get you to see all states that it could be in, all the possibilities. I want you to see all of them. Okay, it went back to 0, but the first qubit is in the 0 state. The second one is in the 1 state. I'll stop when I get where both of them in the 1 state, then I'll stop. Okay, they're both in the 0, 0. See, it's almost like a probability game, almost. It's according to chance. Let's try it again. See, 1, 0. Let's try to get that 1, 1. I'm trying to get the 1, 1. Okay, it didn't give me the 1, 1, so let's go back. I'm gonna keep doing it. Okay, there it goes. I got the 1, 1. So the first qubit is in the 1 state, the second qubit is in the 1 state. So you got to see all the 4 probabilities play out. But it took a while because this is the chances of probabilities for each qubit once it's measured. It can randomly go to either the 0 or 1 state at any time you measure it. So it's not predictable. But that's it.